In this video, we're going to be looking at your 2015 MCQ questions. Let's take a look at your question number 1. Methanol boils at 65 degrees Celsius and water boils at 100 degrees Celsius. So from this first sentence, you can see that these two substances have different boiling point. And then the question continues, methanol and water are completely miscible with each other. So the word miscible tells us that your methanol and water, they are able to mix together. Okay, so now which method can be used to separate a mixture of these two liquid? So with these two information, right, I know that they have different boiling point. They are able to mix together. If you take a look at answer, there should only be one answer. Quite simply, fractional distillation. Okay, since they have different boiling point, I can separate this mixture of these two liquid using fractional distillation. Let's move on to question number 2. 4 bottles containing colorless solution have no labels. So a series of individual tests are carried out on each of the solution. Which bottle contains ammonium chloride? So we just need to make sure that the 3 tests, right, it will show the correct result if let's say it is added to ammonium chloride solution. Let's take a look at the first test. Now, first test involve adding of your dilute hydrochloric acid. Now let's think, when I add dilute hydrochloric acid to my aqueous ammonium chloride, okay, if I add acid to ammonium chloride, which is actually a salt, will there be a reaction? Alright, the answer will be no. There should not be a reaction. So my answer should be either B or C. Or D. I cannot eliminate A. Alright, now let's take a look at test number 2 then. Now for test number 2, you are asked to add warm aqueous sodium hydroxide. Okay, and when I add this warm aqueous sodium hydroxide to my ammonium chloride solution, what will happen? Now, I would like you to recall to your chemical property of your alkaline. If let's say I warm your aqueous sodium hydroxide with an ammonium containing compound like ammonium chloride, your ammonia gas will be produced. Alright, so this gas produced will turn red litmus paper blue. So A is already out. So B and C will give you the correct test result. So now I'm still left with B and C. Let's take a look at the last test then. The last test will require us to add dilute nitric acid and aqueous silver nitrate to your ammonium chloride solution. So you need to recall what is this test about, okay? Adding of acidified aqueous silver nitrate. So you need to know that this is actually a test for your chloride ion. Alright, and since your ammonium chloride contains chloride, you will form a white precipitate when test 3 is administered. So answer for question 2 is B. Alright. Next, let's take a look at question number 3. Question 3. The nuclear number of an isotope, okay, keyword over here, isotope of bromine is 81. So how many protons, neutrons and electrons are present in an atom of this isotope? Now if you go and take a look at your periodic table, you'll be able to see that for bromine, okay, your bromine, right, has a proton number of 35, and of course for this isotope of bromine, then you will have a nuclear number of 81. So you should be able to get this number, okay, the proton number of bromine from your periodic table. Now with this, right, we will be able to find the answer. So the number of proton that is found in an atom of this bromine isotope will be 35. Okay, the number of electron will also be 35. Therefore, my answer actually will be A. Number of neutrons will be simply 81 minus away 35, okay, which will give us 46. So answer for question number 3 is A. Next, question number 4. Why does molten sodium chloride conduct electricity? Okay, so we are looking at your molten sodium chloride. So first of all, you need to ask yourself, sodium chloride, what type of compound is this? Alright, since it's a metal, it's formed between a metal and a non-metal, this is a ionic compound. Right, so your sodium chloride is an ionic compound. And so this question is actually asking you, how come a molten ionic compound, why is it able to conduct electricity? Alright, so this has got to do with the free moving ions. The answer will be D, because the sodium ions and the chloride ions are free to move, okay, when it is in the molten state, because the lattice structure is now broken down. So answer for question number 4 is D. Question number 5. Calculation question. 0.1 mole per dm cube of hydrochloric acid reacts with 25 cm cube of 0.2 mole per dm cube of your aqueous sodium carbonate. The equation for the reaction is shown below. What volume of acid is required to neutralize exactly this volume of sodium carbonate? So first of all, you need to realize that your sodium carbonate over here, this is in the aqueous form, right? So basically, I have two solutions. This is basically a titration reaction. Alright, so since this is a titration reaction, what I can do is that I can use our shortcut method, which is your C acid V acid over C base. B base is equal to number of mole of the acid and the number of mole of the base. Okay, so I can use this formula. So all you need to do is to sub in the value. For the volume, right, you can just leave it as 25. You don't have to convert it to dm cube, okay, because this equation will take care of it. So over here, right, I have the concentration of the acid, which is your 0.1 mole of the acid, multiplied by the volume of acid, which is what I want to find in my answer. So volume of acid over concentration of your sodium carbonate, volume of sodium carbonate will be equal to, now this number of mole of acid and number of mole of base, right, you'll be able to get it from the equation over here. So the equation is already given to you. Number of mole of the acid will be 2, number of mole of your sodium carbonate will be 1. So this will be 2 over 1. Now all you need to do is to just cross multiply, bring this whole thing over your volume of the acid, do some simple calculation, you should be able to get 100 cm cube. Alright, so the answer will be A. Question number 6. 4 different solids W, X, Y and Z are dissolved in equal volume of water at 20 degrees Celsius. The table shows the change in the temperature when each of the solid dissolves. So over here, I have some changes in temperature for W. Change in temperature, positive 10. For X, it is a negative 8. Okay, for Y is negative 5. For Z is a positive 15. So which row of table describe the energy changes when each of this solid is dissolved in water? So the first thing that you need to understand is that when there is a change in the temperature, if let's say the temperature of the surrounding increases, that means that this is an exothermic reaction. Okay, because energy is given out to the surrounding. If let's say the temperature of the surrounding decreases, which is shown by a negative change in the temperature, that means there is an endothermic reaction. Alright, so let's take a look over here. So for W over here, W is here. W has a positive, there is an increase, right, in the change in the temperature. So it should be an exothermic reaction. So this is actually wrong. So A is wrong. X, exothermic, okay, there is a decrease in the temperature, so this should be endothermic reaction, so this is wrong. C, X is an endothermic reaction, yes, because there's a drop in the temperature, right? What about Z? Z, there's an increase in the temperature of the surrounding, so it's exothermic, okay, so now you have your answer. Answer is C. Question number 7. Equal mass of copper carbonate are reacted with 20 cm3 of 1 mole per dm³ of your sulfuric acid. So you have copper carbonate reacting with sulfuric acid, metal carbonate reacting with your acid. Okay, the equation is given over here. So you have your carbon dioxide that's being produced. On which condition will the carbon dioxide produce the most rapidly? So let's take a look over here. Two differences between A, B, C, and D. So for A and B, I'm using powder. For C and D, I'm using lump. So over here, which will have a faster rate of reaction? Quite obviously, right? Your powdered copper carbonate, because of the larger surface area that is present. So I can now eliminate C and D. And then between A and B, the difference is the temperature. Quite easily, your answer then will be B. Okay, at a higher temperature, your rate of reaction will be faster. Therefore, carbon dioxide will be produced the most rapidly. Out of the 4, answer will be B. Question number 7. Parts of some chemical reactions are shown. Which of these reactions represents oxidation? Okay, so let's take a look. Oxidation. For first one, now I have my chlorine molecule, Cl2, ionizes to give me Cl-. So is this the oxidation or reduction? In this case, right, I will be looking at the oxidation state. So for chlorine, right, oxidation state is 0. Over here, it became -1. So it's a decrease in the oxidation state. Okay, so this is a reduction. Copper oxide becomes copper. There is a loss of oxygen. So this is not oxidation, obviously. Again, over here, for the third one, let me just scroll this up. For part C, oxidation state of my iron 3 plus is +3, to iron 2 plus is +2. So again, there's a decrease in the oxidation state, so this is not oxidation. And for the last one, D, there is an increase in the oxidation state. Okay, why? Because for zinc, oxidation state is 0. Zinc ion Zn2 plus oxidation state is +2. So there's an increase in the oxidation state. So this is the oxidation reaction. Answer D. Alright, next question. Question number 9. A student tests 4 different solutions with universal indicator. So the color with the universal indicator is purple, green, red, and yellow. So what are the pH value of these 4 solutions? So first thing first, you need to know that for purple, right, I'm looking at very strong alkaline. So maybe this is between 12 to 14, okay, pH 12 to 14. Green obviously is neutral, so it's about 7. Red, strong acid, maybe between 1 to 2. Yellow is weakly acidic, so perhaps from maybe 4 to 6, okay. So with this, right, you should be able to answer the question. So let's take a look for P. P is a purple solution, okay. After universal indicator is added to solution P, it turns purple. So I'm looking at very strong alkaline over here. So D will satisfy this. Let's check for the rest. Q, pH 7, R, pH 2, S, pH 5. So it satisfies everything over here. So answer will be D. Next, question number 10. An element X forms an ion X3-. Okay, X3-. Which group of the periodic table is this element found in? So let's digest this information first. If your element X forms an ion of X3-, it means that it would have gain 3 electron. Okay, so you will have gained 3 electrons to form this X3 negative ion. Okay, so which elements in which group of the periodic table will need to gain 3 electrons? Definitely not metals, because metals lose electron. So X is going to be a non-metal. Okay, and since it needs to gain 3 electrons, right, I can deduce that your X is found in group number 5. Okay, because it has 5 valence electron, it will need to gain 3 more electrons to obtain a stable electronic configuration of a noble gas. So your answer will be C for question number 10. Question number 11. Which row shows the property of a group 1 metal? Okay, group 1 metal, take note, they are not typical metal. Group 1 metal density, they have very low density. Okay, they don't have high density like your transition metal. Hardness, it is also soft. They are also very soft. Okay, they are soft and can be cut easily using a knife. So answer will be D. Next, question number 12. Question 12. Which substance represents a metal? First of all, metal, usually what state will it exist in at room temperature? Okay, metal will usually exist in a solid state, so A is out. This is not our answer. Melting boiling point, metal usually is high. D is out. Malleability, yes, metals are malleable. Okay, conduction of heat and electricity, obviously metals can conduct heat and electricity. They are good conductors of heat and electricity. So answer will be B. Question number 13. Water is formed when hydrogen is passed over heated oxide of metal L. No water is formed when hydrogen is passed over heated oxide of metal M. Okay, so hydrogen is formed when it is passed over heated oxide of metal L. It's not formed when passed over the heated oxide of metal M. Which row shows the correct order of reactivity of hydrogen, metal L, as well as your metal M? Now we take a look at the statement again. Water is formed when hydrogen is passed over heated oxide of metal L. What does this tell us? This tells us that your hydrogen is more reactive than your metal L. Okay, so hydrogen is more reactive, therefore is able to displace your metal L from its oxide. Alright, so hydrogen is more reactive than metal L, but for this, right, no water is formed when hydrogen is passed over heated oxide of metal M, therefore your metal M is more reactive than hydrogen. So therefore your hydrogen is not able to displace your metal M from its oxide. So hydrogen more reactive than L, but M is more reactive than hydrogen. So the answer will be D. Hydrogen is more reactive than L, but less reactive than your M. Alright. Question number 14. Most aluminium cans are made from recycled aluminium. Why are some aluminium cans still made from aluminium extracted from its ore? Does ore produce better quality aluminium? No, should be the same. Demand is not met by the recycling of aluminium alone. Alright, so answer is B. Alright, recycling alone does not meet the demand, okay, of the amount of aluminium we are using. Therefore, we still need to extract new aluminium from its ore. Next, which row does not match an atmospheric pollutant to its source? Carbon monoxide, complete combustion of fossil fuel. Okay, the answer is A. Alright, carbon monoxide is not complete combustion. Remember, it's incomplete combustion. Then we can just take a look, check the answer just in case. Nitrogen oxides, car exhaust, yes. Nitrogen oxide from lightning activity, yes. Sulfur dioxide from volcanic eruption, yes. Okay, so answer is A. Question number 16. Naphtha is one fraction obtained from the fractional distillation of your petroleum. What is the main use of naphtha? This is a recall question. Answer A. Okay, it's used as a chemical feedstock for the petrochemical industry. Question number 17. Alkanes are a homogeneous series of compounds. The properties of alkanes changes as the size of the molecule increases. How does this property change? Boiling point increase? Yes. Flammability increase? No. Okay, flammability decreases as the molecules get larger. Flammability decreases? Yes. Okay, so this is correct. Viscosity increases? Yes. Okay, the larger the size of the molecule, right, the more viscous it is. So the answer will be B for question number 17. Next, which hydrocarbon is an alkene? So you need to know alkene general formula CN, just use a red color, H2N. So then after that you just need to take a look at the four formula, see which of this fits into this general formula. Answer is A, C5H10. Question number 19. The repeat unit of polypropylene is shown. Which row is correct? What is the name of the polymer? So this is polypropylene. The name of the monomer, the name of the monomer will be your propene. So A, B out. Then what is the formula of the monomer? Now you can either deduce the formula from the formula of the polymer. If not, then just take a look at this. This is a 3-carbon alkene, therefore C3H6. Alright, answer C. Okay, from this formula you should also be able to get the formula. So over here, right, all you need to do is to form back the carbon-carbon double bond between the two carbon. Okay, let me just erase this off. So I will have the chemical formula, okay, which is your C3H6. Last question. An organic compound E reacts with your acidified potassium manganate 7 solution, causing it to change color. So what is E? Okay, so basically your compound E, right, is oxidized, okay, by your potassium manganate 7 solution. So this is a recall question. Your answer will be C. Alright, so answer for question 20, C. So these are the answers for your 2015 Combined Science Chemistry paper.